Hello all, good evening. Welcome to this evening's webinar on Inspiring Middle School Mathematics. We have the webinar on middle years calculator computer software for mathematics. The first question to consider, of course, is which calculator or software are you using? Now, the brief for this evening was to look at student engagement, employing the use of TI handheld technology, which of course is a very, very broad thing. There's a vast range of technologies available under that banner. So I looked at the title, which said Inspiring Middle School Mathematics, and thought, well, that's probably implying the TI-Nspire calculator on your screen now. That is the one that I use in my classes. But the school I've been teaching at, we book list Nspire from years 10 through to year 12. I'm in Victoria. But for years 7 to 9, and I've had quite a lot of year 9 classes, we book list the TI-30. That's a scientific calculator. Now, support for that, I actually oversaw a project about 8 or 9 years ago, which we called National Statements of Learning Initiative, national statements, and this predated the Australian curriculum, so there was just some statements which were guidelines for that. So we put together some lessons using the TI-30. Look at the list of names there. You've got David Tynan, Peter Fox, Ian Edwards, Matt Scoss. So, some pretty clever people writing some very good lessons, and that was distributed to schools in a CD-ROM package with some lessons in an A4 printout. Now, if you don't have that, what I've done, it's quite large, I've uploaded the whole thing to a Google Drive. So that's the link if you wish to download lessons for that. That's the TI-30 calculator and those lessons. Also, the TI-15, which is generally considered a primary school calculator, part of that project was a set of lessons specifically for that calculator, the TI-15. The school I've been teaching at is a K to 12 or P to 12, and we have sets of TI-15s for the primary school component or elementary school component, and so that's there as well. So we've got all three of those calculators used in my school. So there's the links if you wish to access those lessons. The lessons incorporate student activities, teacher notes, assessment instruments, and PowerPoints. And a reminder that you will get a copy of this PowerPoint after the webinar, so no need to pencil down those links. You will get a copy of the webinar, so you'll be able to just click on it. So that's the consideration. Which calculator do you use when we've said this is for middle years? But for this evening's webinar, we're mostly going to concentrate on Nspire, and I'm going to cross now to Melissa to tell you her classroom story. And I've been at a conference just recently with Melissa, and I attended a session that she presented where she shared what she's doing in her classroom, not just with TI-Nspire, but particularly with Inspire Navigator, which is a Wi-Fi Connect system. So she has the ability to send files to all the students in her class, have them do some work, and then collect that back from them.
Thanks,
Melissa,
Yeah. Thank you for that. And as Brian said, I was lucky enough to travel with a number of TI trainers from throughout Australia over to the international conference. I'm going to start off by answering Brian's question of which calculators do you use. At my school, similar to what Brian was saying there, is in years 7 through to 10, we book list the TI-30. We encourage the students to use the TI-30. We have what we have purchased and we've been able to get also through the volume purchase program that TI runs is then emulator software to go with this for our teachers at school, so that not only do the students have the calculator, but the teachers have the software available on their computer to be able to demonstrate. And I find that really powerful, having that information. Interestingly enough, just last Thursday I was wanting to demonstrate something to my students and went to my computer, forgetting that I had had a change of computer only about a month ago and had not fully uploaded all my software. So it was actually, I found it difficult to teach without the emulator software. So that's what our students do have. There are some students that have non-TI calculators, but it is recommended that we have the TI-30. We do have, or what I'd like to see a lot more of, is the use of the TI-Nspire in our junior years, in our middle school years. We have got 3 class sets of 25 TI-Nspire in my school that are available for students or teachers to take into classrooms and use. It's a matter of obviously making sure the teachers are comfortable with doing that. So I'm trying to do as much as I can to do that. We do have, you'll see on the screen there that I've got the TI-84. I've got an old version of the TI-84 and a picture of the newer version, the CE version. We do have some students that have the 84s. We used to use 84s in our senior school, and so those have been passed down to younger siblings who are in our junior and middle school now. So there is some of that, but we don't have as much. In my senior classes, I do use the TI-Nspire, and as Brian mentioned, I actually use the TI-Nspire in my Year 8 class that I've got at the moment with the help of the Navigator system, and I'm using that from a point of view of formative and also diagnostic assessment of the students throughout various lessons, most lessons, and the students are actually really enjoying using the calculators as well, what they're able to do. Just to show you on the topic of the emulator software that you can get, what I do have is a version of it here. Something that I did do just last Thursday. We're studying probability at the moment in my Year 8 class, and so I was able to demonstrate to the students how to use probability and in particular to generate random numbers, because I had wanted to do a dice activity in class and managed to leave the dice sitting on my desk in the staff room. So it was like, well, okay, well, let's do this from a technology point of view. We don't have to have the actual dice. We can actually generate random numbers. And I showed them how easy it is through the probability button, choosing right arrow across to random, R-A-N-D, choosing number 2, random integer. We put in, because I wanted to simulate dice, we put in the number 1 as our minimum value. We put in a comma, which is second function in the decimal point, and then number 6 as our maximum value, and close the brackets, and we generated our random numbers. And each time they hit enter, we got a new random number. So I was able to run my dice activity without actually physically having dice. And the students thought that was pretty cool. They hadn't done something like that before. So having the software would have made that so much easier than me just describing what they had to do. So needless to say, I have since gone and installed my TI-30 emulator software to be able to use. But that's a very basic activity that you can do, and at any time you can have students generate random data. And I even set them that task for homework, having done it in class, that they then had to generate 30 random numbers between 1 and 10, I believe I set it as, for them to then do frequency tables and look at experimental probability. So something very easy you can do.
Really, really useful. And the fact that it's not just limited to a 6-sided die, is it, to a cubic die?
No, you can make it whatever you want. If you wanted to, you could do flip a coin by making heads number 1 and tails number 2. You can run a 10-sided die, and you say to students a 10-sided die, they've got no idea that there are that sort of thing out there. So it is always nice to have a picture or actually have a 10 or 12-sided die for them to see that you can actually have them, but you don't usually have enough of those in the classroom or in the school for every student to have one to generate data, so you can always do that. So that's my story of what we have in my school. I am lucky enough as a trainer to have a set of TI-Nspires that I can use with my class and the Navigator system, and I, as I said, do use it a lot. So for tonight's webinar, in terms of we're looking at providing you, inspiring you as teachers to use the calculators more in the classroom. So random number generation is one area. As I said, I'm teaching Year 8 at the moment, and our topic is probability. And another activity, and that random number generation can be done just as easily on the 84s and also on the TI-Nspire. That always works really well. But another activity that I want to have a look at, something very different, and I've not looked at this, I haven't actually run this with my class yet, but it is an activity I'm going to be doing next week with my class, and that is something that is called non-transitive dice. Now, I hadn't heard of these non-transitive dice until last Saturday, and I was lucky enough to be at a professional development conference here in Brisbane on the Sunshine Coast, and the guest speaker was Adam Spencer. Now, I've got 3 of his books. I really like the activities, the way he does it, that sort of thing. And he was speaking about these non-transitive dice. And then when we were looking at the presentation for tonight, it was suggested I look at something called Grimes dice. And if you go to the YouTube, I've got the link up there. You go to YouTube and just put in a search for Grimes dice, and you get this video that talks about these non-transitive dice. So I thought it was quite funny that I'd never heard of them until Saturday, and now I've had 2 experiences of them, and I really like them. So I thought we'd have a look at it. So the transitive process, or in maths when we talk about transitivity, we talk about the fact that if you're looking at the picture I've got up there where I've got 3 dice, and if I say that the red dice is better than the yellow dice, and the yellow dice is better than the green dice, or will beat the green dice rather than better than, then you would expect that the red dice would therefore beat the green dice. That's transitivity. However, because these are non-transitive, it actually doesn't work that way. And so what we're going to do is have a look at the situation. Now, the video, the YouTube video, which is really good and explains it really well, and so does Adam Spencer, but I couldn't get him to talk on here tonight for me. The idea is if you're playing a dice game against somebody else, and you've both got standard 6-sided dice numbered 1 to 6, then it's actually 50-50 as to who will come out and win, okay? Because if you're saying that the larger number is the winner, then you're going to end up with you'll win some and your partner will win some. But if you want to set up a situation where you always win, then you look at the numbers that are on the dice. And you can set up this situation using your calculator in terms of, and I've just realised I've opened up the wrong document. But,
down the bottom there, yeah.
No, it's the one document. I changed computers this afternoon. So I'm going to start a new document. And what we can do is we can actually put into our document a loosened spreadsheets page. And if I set it up that I have my red dice, I have my, I'll call it blue just because that's what I started doing, and a yellow dice, okay, if we go back to the picture, you will actually see that the red dice here has 5 sides with the number 3 on it and 1 side with a 6. So if I put that in, so my red has 5 sides with the number 3 and then the number 6. And then I go to my blue dice, which I'm actually using it instead of the green in the picture. So it's got all number 4s and then a number 1. And then my yellow dice which has 3 number 2s and 3 number 5s. What we can then do by adding in a calculator page is we can ask for a random sample from green. No, I didn't have green, did I? From blue. And I want one number, and I will get a random sample from there. So I've just taken the random sample instruction, the blue, which was the heading of the particular column, and I want one sample. And each time I hit enter, I'm going to get, in this case with the blue, either a 1 or a 4. Now what I'm also able to do looking at this is put in random sample blue, and then put in my greater than, except that I've all of a sudden forgotten where my greater than is.
It'll be in the...
there it is.
Yeah, just below the control, yep.
Yep. And I put in random sample of red and do 1. Now when I hit enter, it gives me the answer true. Well, that means that I've rolled my blue dice, I've rolled my red dice, and the value that has come up on my blue is greater than the value that's come up on my red. So in this case, it took me 3 goes before I got false. Now I could do the same thing looking at the red and then the yellow, but the interesting one is if we change it and I do, no, I will actually do red to yellow. And what happens here is the red beats the yellow in more cases. There it's come out 50-50 on me. But if I do yellow over the blue, or the blue over the yellow, it actually goes the other way. And what you get students to investigate there is, well, what's the average as such? And you can get it to do a mean calculation on red. You can if I put in the instructions correctly.
Mean red. Do you not want the 1 in there?
That might be what it is, yeah. That's better. I didn't want the 1. I've put too many 1s from doing it before. And what we actually see is that the choice of values on those dice actually gives them all the same mean. However, the situation is that the red will beat the yellow will beat the blue, but then the blue actually will beat the red, and it goes around. Now, I thought that was really interesting, and you can get students to investigate. You could even ask them to come up with a combination of values on their own dice that they believe will always beat their friend, and then play it off and gather data on it. So that was something there, and interestingly, with Adam Spencer, he's got this activity in his latest book called The Number Game. Not wanting to plug Adam Spencer, but it's a really good book. And it's one of the activities, number 24, and he's got 3 dice in there that he calls die A, die B, die C, and they're different numbers again. So you could ask the students to have them face off and see, well, okay, who does win in that situation? So I thought that was really interesting, something that we can look at that's not the standard, let's go and roll a dice 100 times and find the experimental probability of getting a 2. We can try other things, and that's using the listen spreadsheet and a calculator page. So I thought that one was really interesting. Another activity, I am conscious of time, and I know that Brian has lots of things to look at. So another thing that I like to do is not just do our algebra in terms of x plus y equals 7, or let's graph all of these linear functions or these quadratics, but actually do it via an activity. And this leapfrog problem is a fun activity that you can have students to actually physically play, so you get out some markers, but as well, it has been written up as an activity. And if you go to the Australian education.ti.com Australian site and go into Australian Curriculum Inspired, there's activities in there set out for all of year levels 7, 8, 9, 10 and 10A, and under number and algebra, statistics and probability, and also measurement and geometry. And so this is on here, this activity, and it goes through and it says, well, okay, the object of the game is to get all the frogs from one side to the other. So in this case here, the frogs can go forward, or they can jump one, but they can't jump 2. And I need to get all my green frogs to the right and all my red frogs to the left. And what you're looking at is if we have 3 frogs on each side, how many moves does it take me, the minimum number of moves? And I always manage to actually get this wrong. So
yep, you're not alone there.
Every time I do this.
Yep.
So I've made a mistake here because I'm going to end up with all of my red frogs together, and the only one that can move is my green frog, and nobody's allowed to go backwards. But the nice part about this is that you can reset. So when you go into
Melissa, I know the formula, I just forget the strategy.
Yeah, I forget the strategy all the time. I'm using it in the
workshop this week.
So what you do is you either choose reset, or the good thing with this one too, the way it's been set up, is if we decrease our frogs, the students are able to start with, if there's 1 frog, what do they get? If there's 2 frogs, what is it? And then the other thing is, you can actually then have them fill out the table, the listen spreadsheet of, all right, well, when there's no frogs, what's happening? Well, then there's no leaps, no creeps, no moves. When there's 2 frogs, that's 1 on each side. So we do have to remind them that it's not 2 frogs there is not 2 on each side, but it's actually 1 on each side. There are 2 frogs in total. How many leaps was it? How many creeps? Well, that's a shuffle straight across or a slide. And therefore, how many moves in total? And when you go through that and actually fill out the table, it will actually send the data across to graphing so the students can then analyze it. And so rather than, here's a set of numbers, plot it and find out what the equation or the function is for it, let's get them to do an activity, and it's going to engage them. It's hands-on, and you can start with the hands-on one, but the nice part about this is that because we can increase the number of frogs, then they're able to do it fairly easily without us having to have an unlimited supply of counters that the students are going to throw across the room at each other, etc. So I like those sort of activities, and again, it is just straight off the education.ti.com /Australia website, so very easy to find.
Yep, I'll just put the link into the chat for anyone who's looking for that. So I'll link directly to that activity. Yep.
Another one, also similar spot, is the good old Tower of Hanoi. And again, trying to get hold of enough of these for students to do, or get them to cut out the discs and that sort of thing, can take a time. So you can play it on here, and you actually have to move the pieces. And you go through and you place the piece, and if you try to put the larger one on top, it's not going to let me leave it there, because it says, no, that's not allowed, because with the Tower of Hanoi, it's got to be a smaller one on top of a larger one. So I have to then move, and you'll notice with each one, it's counting my moves for me, so I can then have a look at how many discs do I have, how many moves, and again, come up with that graph to then look at the relationship there. So a couple of activities that I know I've done in classes previously that I sort of go, oh, it'd be really nice to have this so that every student could do it individually, and the Inspire makes that possible. Obviously, the TI-30, because it doesn't have that interactivity, that doesn't have that screen, you're not able to, but it is still a really good calculator, and you can still do, obviously, your probability. You can still analyze things. You can still put a table of values into your TI-30. You can enter in via a Y function there as well. So that's your Y equals, enter your function in X, or the other option is your data. So you can make list one your move. So the students can still be recording that, but they don't get to see the graph of it. You obviously would have them draw that by hand. You can still do the activities, and you've got your calculator there to support you in doing them. The last thing that I was going to, or topic I wanted to very quickly mention is trigonometry. Something that I've had students do in the past when they first are introduced to trigonometry is this concept that no matter what size triangle you have, trigonometry is based around these angles, and I've had students actually drawing up all these different triangles, but we all know as teachers it can take students forever to draw a triangle, and there goes half your lesson. And so the nice part is with this activity, similar signs, is that the students are able to investigate using the calculator, and it's so much quicker. So if we go, as it says, use the sliders to adjust the size and shape and record the angle and the measurements in the table. And there are worksheets with all these activities. When you go to education.ti.com, there's worksheets, there's teacher answer sheets for it, and it gives you other ideas. So with this one here, you're changing your angle, so that's 30 degrees, and if you want to grow it, you can see that that angle of 30 degrees does not change. It's just those measurements. So you're able to demonstrate to students and have them investigate that it is a ratio, hence we call them trigonometric ratios. It is not sine times by the angle or cos times by the angle, and that no matter what angle we use, okay, that ratio remains the same. And that's where you can be looking at the ratios and see what it is each time. So these sorts of activities, these sorts of demonstrations are actually really important in terms of helping students to really understand and embed the knowledge that we're trying to get across to them. And that's where as well, having the likes of TI Navigator, where I can send out a quick poll, like what I noticed Brian popped up on the screen before, with a quick poll of what calculator do you use. I do that in my classroom, and we're getting that information back. So it makes it so much easier, I think, to teach students when we've got the likes of these resources at our fingertips. That was mine,
Yeah.
Brian, and I'm sorry I have gone a little bit over what I said I was going to do. So I'm going to hand it back to you and allow you to then take the rest of the time, and I do apologise for taking up a little bit of your time.
Absolutely fine, and thank you for your sharing of those ideas. And for our listeners, look, obviously not necessarily new puzzles there, new problems. Trigonometry, for goodness sake. I remember illustrating that. Like, I've been teaching for 30 years. I remember illustrating this with cardboard cutouts and pieces of string with a plumb bob on it, you know, weighting something down off triangles and circles. You know, the ideas are the same. The technology is just helping my life in presenting it, and hopefully the student's life in seeing how it works. Tower of Hanoi, for goodness sake, you know, how old is that problem? The leaping frogs, as you said, Melissa, I'm actually using that activity later this week, and I can never remember the pattern. I know the formula. It's X squared plus 2x. I know that. And so it's a lovely way of introducing quadratics to build up the table, and that's what it is. It's just simply, if I vary this, such as the number of frogs per side, then what is the response variable? Then i.e. the number per side. Yeah. So it's just a much more hands-on, intuitive way to get into it, and kids love to fiddle with it. And can I also please emphasise, I'm sure our listeners are aware, this is a computer-based webinar. We're using technology, but in your classroom, for goodness sake, please use also, you must marry this with concrete manipulatives. Give the kids the counters and little plastic frogs, if you like. They've got to do, disc upon disc for Tower of Hanoi. You must have the hands-on manipulatives to introduce the idea, and then what happens with the technology is once you see a pattern, you can expand the pattern to much greater numbers with the power of technology. That's where technology really comes to the fore, in my view.
Absolutely, I fully agree.
Yeah. Your transitive dice, your transitive dice, I remember seeing that in, I think I've got it right, MCTP, Mathematics Curriculum Teaching Project or Program, from Victoria's Curriculum Corporation, Charles Lovett and Doug Clark. That lesson was in there, and that's from I think the 80s, or it may have been in the Chance and Data version of that, which was Charles Lovett and Ian Lowe, which was in the 90s.
Yep.
Yeah, great activities, and whichever technology you're using, you're just using that to help kick it along, and maybe save a bit of classroom time and help illustrate it for students. So my introduction for TI-Nspire was at the Year 9 level. You may recall my Year 9 students had book listed the scientific calculator, that's the TI-30, and I had a program where we had our main topics, we had a homework topic, program, and also I was in a situation where we could do some team teaching. Adjoining classrooms, we opened up the door in the middle, so myself and another teacher took, shall we say, special team teach focus topics, and we had a couple of those each term, calculators being one of them. And what I did there, come on, I'm a national T-Cube trainer, and my school has book listed the Inspire from Year 10 onwards, but I still go back to Texas Instruments headquarters in Melbourne and borrow a loan kit. You see on the bottom right there, the loans program. Marie Wilson is the person to talk to. You'll get the phone number at the end of this webinar. Talk to Marie and say, hey, I would like to introduce my middle year students or lower level students who don't yet have TI-Nspire. I would like to introduce them to that before they have it book listed. And you get the class kit as a loan. That's fantastic. So Marie is lovely. She'll help you out with that. She's also a Richmond supporter, which makes her extra lovely. And Go the Tigers opening game tomorrow night. I will be there. And you see on the left here, volume purchase program. I'm using Navigator in my class, and I have the software. But to get the yellow Wi-Fi caps that fit upon each calculator, and the charging bay for the calculators, we actually bought that. Well, we didn't buy. We got it through the volume purchase program from our school. We kept the receipts for the calculators that we'd bought through the school and then on-sold to students, and we got that for free. So we've got 3 charging bays with yellow caps that tie into the Navigator system. Cost us nothing. The loans program cost us nothing, and it's working very well.
On that topic, Brian, with the volume purchase program, as I said, that's how we've got over 25 copies of the TI-30 emulator software for staff at school, at my school, is through the volume purchase program. And as you said, we've got a set of Wi-Fi hats, the yellow Wi-Fi hats, the Inspire, that we got through that. And as well as that, I think we're up to 6, no, it must be 9 of the charging hubs that we've got all through the volume purchase program, through the fact that our students have to buy the Inspires and we just keep a copy of the receipt. So absolutely, it is an amazing program that's run.
Yep. I mean, you're missing out if you're not using it, I reckon. And thank you for raising that point with the emulators. It was actually a question through chat while you were presenting. Someone said, hey, how do I get hold of that TI-30 emulator? That's the scientific calculator. And you're right, that's also available through the volume purchase program. So for my introductory lesson, remember I said that I oversaw the project where we were writing lessons for not just the TI-30 but the TI-15. So I've actually taken one of the TI-15 lessons. Remember, that's initially written for primary school. Vince Geiger wrote that. He, former president of AAMT, lives in Brisbane. Yeah. So I took Vince's lesson and adapted it with the TI-Nspire. In that package, if you follow the link that I sent, there's a PowerPoint. This is Vince's PowerPoint here. So the front page links through to the teacher notes, worksheets, assessment task, solutions, etc. And here's his PowerPoint here. Now, Melissa, I'm hoping this is coming up okay on your computer. It's very slow on my mirror computer here.
Yes, it was quite slow, but it has come through now. There it is.
I've got tap on the shoulder. Now, the lesson, it's a simple idea. How long does it take if you have a line of people, the person at the back taps the next person on the shoulder, and the tap continues through to the person at the front? So students love this because it's hands-on, it's physical, it's kinesthetic. We get it going with a stopwatch, bang, bang, bang. We have estimations, do the recording. It's a simple collection of data. As you can see, Vince actually used his family as models for his PowerPoint. So there's the problem that he put up. His PowerPoint talks a bit about number patterns in general, building to linear patterns, which this one is, and so we have the discussion about that. Remember, I'm coming back to my Year 9 class, so linear patterns and linear functions is an important thing. Worksheet for students, and then an associated graph. So they get, pen, paper, worksheets for this. And in Vince's lesson, he was exploiting the repeated operations function on the TI-15 calculator, which is terrific and great for hidden functions as a game I like to play. It's like function machine games. But with my Year 9 class, I was introducing the TI-Nspire calculator, so we did it on that. We used the lists and spreadsheets. We produced a statistics plot, and we did a regression. That was a good introduction for them with this calculator, problem-based. For the topics they're doing, we also did work with Pythagoras' theorem, indices, and the fact that you've got a calculator that can handle really big numbers. You see I've got there the story of chess. I don't know if you're familiar with it. It's probably a bit of a fable, but the deal being that the payment from the mathematician, the royal mathematician who invented the game of chess to appease the king said, "Look, this is fantastic. Ask what you would like as payment." And the humble mathematician said, "Sire, it's just an honour to have invented this for you. I only ask 1 grain of rice for the first square on the chessboard." "Okay, double that for the next, and double for the next." And of course, you go along 8 squares, and you've got 2, 4, 8, 16, 32, etc. It's about a handful of rice by the time you've got to the end of the first row on the chessboard. But by the time you take 2 to the power 64, it's a considerable number, which most calculators can't handle. The TI-Nspire can, and it can graph it. So that's a good one. Expanding and factorising, just using the algebra commands. Kids love that. Of course, trigonometry, in my view, the biggest topic to be introduced at Year 9, one that kids love. Of course, they only really need a scientific calculator to process trig functions, but to graph it and see the cyclic nature, they really appreciate using a graphing calculator such as the TI-Nspire. I have a few slides here for you, each with 3 things on. I'm only going to illustrate one, but in the package of materials that you get from this webinar, I'm going to send you all of these. They're actually all available from the website. I'll click on this, that Melissa referenced before. You see I've got linear functions assessment, distance between 2 points, and some basic algebra. And while my computer responds to that, the Texas Instruments website, Texas Instruments Australia, if you Google, if you just simply put Texas Instruments calculators, you'll probably end up in Texas. If you type in education.ti.com, you will end up in Texas. What I suggest you do is Google Texas Instruments Calculators Australia. Look, the Texas site is okay, but ours is better. And the area to look at is under Teachers, Australian Curriculum Inspired. So you've got so much stuff under the Teacher Resource Centre, but Australian Curriculum Inspired. If you're also taking senior classes, Senior Curriculum Inspirations. That's a play on words for Inspire. And as Mel said, you get a lesson to download in 3 parts. You'll have a student worksheet, you'll have a worksheet for teachers which contains the answers, and you also get a calculator file associated with that. So the one that I've chosen to demonstrate for you, a lot of them are in tests, which again I thought was a good way to introduce this to my Year 9s. Like Mel, I was using Navigator, so I had the power of sending a file to every student calculator. Remember, this calculator is new to them, so they're holding a device in the classroom. I've got my laptop at the front. They see my computer screen up on a big screen, a shared whiteboard, and I send them a file and say, well, here's a test. Could you work on this? So distance between 2 points. All 4 of these, by the way, are in the shared document that you'll get at the end of this webinar. But the distance between 2 points, here's the three. One of them contains the answers, the other not. So here's the TNS file, TI-Nspire file, and coming onto your screen now. Page 1 instructs the students on how to navigate through their document, and they go to the next page, and it's just a multiple choice. Okay, so the distance between A and B equals what? So we'll click on this, and we'll continue on. And if, what have we got? Q and S are the same, so the distance between them will be what? R minus P, and so on. So I've just got 10 questions in this. If students are smart enough, they can actually take a measurement. But remember, they're not used to using these calculators. But they can actually get into the file and find the answers if they want. And good luck to them if they do. Peter Fox wrote these, Peter Fox, Texas Instruments, Australia. And if you're using Navigator, the benefit is when students submit the file with their answers, Navigator will automatically mark it and drop it into an assessment portfolio. So you can set your class up. I know, Melissa, you talked about this just last week in San Antonio. You can set your class up with portfolios for assessment.
Absolutely. It's amazing. And as I said, my grade 8s will use it. They start every lesson by walking in, grabbing a calculator, grabbing a Wi-Fi hat, and they're given 5 questions. That's an addition or subtraction, multiplication, division, fractions, decimals, basic skills, and they're given about 5 or 6 minutes to answer those questions. I draw back their answers. It's already marked, and we go through and have a look at them, and the challenge is to see if we can get the whole class getting 5 out of 5. So far, we've been doing it since about week 2, and the best we've gotten with my year 8s is the whole class has got 2 out of 5 correct. But the interesting thing, yeah, that's a worry. The interesting thing is I use the same set of questions which are based off a Year 7 worksheet. They come from a Year 7 worksheet. I use the same set of questions with my Year 8, my Year 10 Maths Methods Prep class, a Year 11 Maths B class, and a Year 12 Maths B class, and they do the same set of questions for the day. So whatever, on Monday they do question set number 1, or what I call lesson 1. On Tuesday they do lesson 2, and so on. And I play them off against each other, particularly the 12s against the 11s, in terms of, all right, grade 12, the year 11s did these questions earlier today, and they only got 1 question where the whole class got it correct. Can we beat them? So far, the grade 12s had their best day yesterday, and they got 3 questions fully correct. They're also trying to get me to pay them with chocolates, and I said, well, if you can get the whole class gets 5 out of 5, I will buy each person a chocolate. I don't think I need to do chocolate just yet.
Bribing.
I told them, though, that they might have to start buying me chocolate. But, yeah, absolutely love the Navigator from that point of view, and plan on using it to also send information to parents, as in I collect the data, and then because the portfolio can be dropped into an Excel spreadsheet, and then I can use the information to send out to parents and let them know how the students are going on some basic skills.
It's lovely for parent-teacher interviews. Brilliant.
Oh, yes.
Yeah, and the fact that you can also capture student calculator screens as well at any stage while students are working. You can just capture the whole classroom of screens, and, for example, you might say, please draw me a quadratic. And you get a vast range of things, and most of them will be smiley face quadratics, and some student does an inverted parabola. And so, well, that's interesting, and there's a discussion point. But you can capture all of that and you can show it to parents, parent-teacher interviews, which I think is really really useful. I've flicked back to my slide here on tests and masteries. I've got the sign there, masteries. The idea of sending out a test, fine. Oh, and by the way, if you don't have Navigator, you can still do this by using that that box, that charging box of calculators that I mentioned. You can put all calculators into a box, or you can set it up from your computer to send the file to the to the charging box, and students just walk in, drop their calculator in, or you can have a set of calculators in there, and it automatically takes the file when it's in the charging bay. So students just drop a calculator into the charging bay, accept the file, and move on. Although it is much easier with Navigator. The masteries is another thing that was set up where students take a file and work on it, and it's a quiz, question and answer thing for them to work through, and they're set up in the form of Lua files. If you're familiar with Lua files, Steve Arnold did a lot of work on those, and there's sets of them, basic sets like on mastering fractions, mastering basic algebra, and would you believe I used that with my Year 11 class just to polish up some of the basics. So I gave them those files and I said, work on these during your spare time, you're sitting on the bus or waiting for the bus, whatever, and you're going to have a test on it on Friday. So that's another way to go. So if you look for the, not just tests, but mastery files, and there's actually a lot of those on the American website. The activities from Australian Curriculum Inspired, I've selected 3 here. Circle features, which is again a basic topic, but interactive. It's your standard stuff, your radius, diameter, circumference, etc. But interactive. You can see the reference to the Australian curriculum. So these activities are written, they're downloadable, they're free, they've got student worksheets, they've got answer sheets, they've got a TNS file. The one that I've chosen to demonstrate for you is a Perimeter of Australia. Log into logarithms, I think, is quite good. That's for Year 10. That's one that I wrote, in fact. But the Perimeter of Australia, again, it's another one of Foxy's. You get all 3 in the package. Perimeter of Australia is pretty cool. I'll just show you the student activity sheet. So the deal is you'd download this, print it off for your students. The opening problem, how far is it around the Australian outline? Depends if you're driving or sailing or going into all of the bays. What Foxy did is he took a map of Australia and dropped it into a function page, graphs and function page, and the activity then suggests to students that they plot points around the coast and then use the tools in the software to work out the distance between points. So this has been a good introductory one. Again, I'll just show you how that works. So here comes the TNS file. Instructions within the TNS file. There's our graph. And it is suggested that we plot some points. So menu, geometry, points and lines. Let's just do some points. So let's say I might do a point up here, Cape York, and then maybe down here, down on the Sunshine Coast. So there's a couple of points, and we can plot points around the coast. You've got the idea, and obviously the more points, the more accurate my calculation is going to be. To then get the distance between them, if I go into first of all, actually, what I'll do is I will show the points. coordinates. So there's the coordinates of this point, coordinates of this point, etc. You've got the idea. And then what the activity suggests is we then put in some text. Find where we've got that. So I'll put a text box in here, and I'll make my text box the square root of, shall we say, x2 minus x1. I do actually have the possibility of subscripting the 2 and the 1, but I don't need to. Just be aware that x2 is read as a single variable, so it's x2 is the name of the variable, and you've got the idea. Oops. Instructions for all this are in that downloadable worksheet. So I've got my formula there, and again you can see I've got the text box here. To exit that, I can just click on that. So my cursor is wandering around. We're on a graphs page here, but to evaluate this, I'm in Control and Menu, or right click, and it says, okay, so how are we going to work this out? What is x1? So select the variable x1. So, okay, there you go. So it says, where's x2? Well, there it is. Where's y1? Okay, there it is. Where's y2? There it is. And it's calculated a number, you can see, 8.17. So it's saying that on the scale of this map before you, the distance between the point 13.2, 13.5 and 16.9, 6.3 is 8.17 units, something that a Year 9 student should be able to calculate anyway. But they've got this interactive thing here and a problem before them that puts it into a context. Okay, so I'm suggesting that between Cape York and where are we, Sunshine Coast, it's probably more than 8.17 kilometres or whatever. There's a scale factor involved, and if we go back to the activity, we've got a table to record our results. The scale factor is mentioned when I find it. 1 unit on the map is 240 kilometres. I'm seeing that there actually is a bit of a delay between my screen and yours. I have a mirror computer set up, but in the notes, 240 kilometres is equal to 1 unit. So in this program, if I take that 240 kilometres multiplied by 8.17, we'll get the distance between those 2 points. And you've got the idea. We can continue around the coast to work out the perimeter of Australia. Don't forget Tasmania. For our Tasmanian listeners, you will have to do that as a separate calculation. So you get all 3 of those activities. Can I also just quickly mention, I know we're on time, STEM activities are also involved there. There's some lovely ones there. Goldbach conjecture, I think, is one of the best. That's in the Year 7 list. Again, in the website, you can see there the Tower of Hanoi. In the website, when you go Australian curriculum, senior curriculum inspiration, STEM is one of the options, or also year. There are some listed in at Year 7 and also at Year 9. And it appears like my screen has dropped out.
I thought that was my computer that dropped out then. I wondered what was going on.
Yeah, Yep, for some reason my computer has dropped out. It might be suggesting we're on time. Other things to look at, you'll see in my PowerPoint when you get it. I'm aware that it's no longer coming through. But I've also got some activities on developing algorithmic thinking. There's a lot of talk at the moment about coding, and I think the calculators are very good for coding and branching into our STEM activities. I really think that an important issue in the lead up to coding is the thinking, the algorithmic thinking that's required of that. There's some lovely activities for that as well, which I'll reference in the PowerPoint. We're on time and my phone is beeping at me on my computer. Okay, you've got my computer screen back again. So a wealth of activities there for you to explore. Please take a look at and explore and enjoy with your students the package of activities that we will send to you. Can I bid thank you to my co-presenter this evening, Melissa.
Thank you, Brian. It's been lovely working with you.
As always, terrific. Now is the opportunity for any participants to type in any last-minute questions into the chat. Also, of course, a facility to say, hey, thank you, Melissa, and Brian as well. You will, when we exit the webinar, be taken to a page where you're invited to type in some feedback. If you like what we've done, my name is Brian Lannon. If you don't, my name is Peter Fox.
And he can't say anything because he's on a plane to Melbourne at the moment.
I know, yes. You will, as a follow-up, gain your certificate of attendance at this webinar, coming soon to an email near you. And as part of that, the package or the links to the activities that we've referenced. Can I also just quickly issue an invitation. If you too would like to have a guest presentation segment in one of our webinars, please talk to us about that. So I'm only talking 5 to 10 minutes. You do that, we will give you a certificate, and it will look good on your resume, I reckon. And of course, we're very interested to hear what you're doing in your classroom. Can be a launch pad to some great professional development. I think there's no better professional development than presenting to our own teaching peers. So either email me or type your commitment-free expression of interest into the chat window. And if you would like to view this whole thing again, it is available on demand through our website or via our YouTube channel. You see the links before you. You probably were taken to this webinar via receipt of our newsletter, or you may have just stumbled across it on the website. If you're not subscribed to the newsletter, then I suggest you're missing out on lots of good things, and that you should subscribe. There is the link there. Any other questions? There's some phone numbers on your screen. One for Australia, one for New Zealand, and I do know that there's clever people on the ends of those phones. Peter Fox when he gets back to Melbourne. And I will once again bid thank you to our co-presenter this evening, Melissa.
Thank you.
And a good night to all.
Good night to everyone. Yes, thank you.